All right, let's talk about the hidden blueprint of our digital world. I mean, how do we go from total random chaos to the connected world we live in today? It's all about something called network topologies. Okay, so picture this. You're trying to get around a brand new city, but there's no map, no street signs, no grid, just a total mess of roads going everywhere and nowhere. That's exactly what early computer networking was like. A digital mess full of traffic jams and just total confusion. And then everything changed. The engineers back then had this aha moment. They realized, wait a minute, the way we actually plug these things in physically, that affects everything. We're talking performance, cost, and maybe most importantly, whether you can even troubleshoot the thing when it breaks. That one simple idea, it literally sparked a revolution in how we connect things.
So let's jump in our time machine and go back to what I like to call networking's Wild West. Seriously, it was an era of total improvisation. Connecting computers wasn't a science yet. It was more like a messy art project, and it led to some major digital traffic jams.
You see, back then, there was no master plan, no standard way of doing things. So what happens when you need to add more computers? Well, it was a nightmare to scale up. And troubleshooting? Forget about it. If one little thing went wrong, you'd be crawling on the floor, checking every single cable by hand. It was just messy, super expensive, and totally unsustainable.
And, eventually something had to give. This whole chaotic, just plug it in wherever approach, it just hit a brick wall. As companies got bigger, the network just couldn't handle it. It just broke.
Let's put this into perspective. I mean, why was it such a big deal? Well, when you've only got, say, 5 computers in a small office, you can kind of get away with a messy setup. Sure, it's not pretty, but you can manage it.
But what happens when that office grows to 50 computers? Suddenly, the complexity just explodes. The number of connections goes through the roof, and the chance of something breaking, it skyrockets. Those digital traffic jams, they're not a rare thing anymore. They're your everyday headache.
Now imagine 500 devices. Yeah, no way. It's just flat out impossible to manage that kind of chaos. At that scale, having a plan wasn't just a nice idea, it was a matter of survival for the business.
So let me ask you a question. Think about a real scenario from those early days, like the very first Ethernet networks. What do you think would happen if just one of the main cables failed?
The answer? Total network collapse. That was the core problem. A single broken cable could, and believe me, it often did, bring an entire office to its knees. Productivity just stopped, all because of one bad wire. But out of all that chaos, a really elegant, simple solution emerged. An idea called network topology. This was the moment we finally started drawing a map for that digital city. So what exactly is it? Well, think of a network topology as the network's blueprint. It doesn't just show you where the cables go. It actually sets the rules for how data flows from one place to another.
And this is a really key point. There are 2 types. You've got the physical topology. That's the stuff you can actually see and touch, the layout of the cables. But then you have the logical topology, which is all about how the network behaves. It's the path that data takes, the rules of the road. And what's wild is that you can have the exact same physical setup behave in totally different ways. Okay, so with that in mind, let's meet the main blueprints that the engineers came up with. Each one is a different approach, with its own pros and cons. First up, we have the bus topology. The easiest way to think about this is like a single main street in a town. Every single device connects to this one main cable, this backbone. Super simple, really cheap for small setups. But it has that same fatal flaw we talked about. If that main street gets a pothole, if that cable breaks, the entire network goes down. Yeah, that's why you basically never see it anymore. All right, next up is the ring topology. Just like it sounds, every device connects to 2 of its neighbors, forming a complete circle. It's kind of like a roundabout for data, always flowing in one direction. But again, you see the problem, right? It's fragile. One little break in that ring, and boom, all traffic stops. And that brings us to the star of the show, literally, the star topology. This is the one that really solved the problem. In a star, every single device gets its own dedicated connection to a central point, like a switch. And its biggest strength? Resilience. If my cable fails, it only affects me. Nobody else cares. That reliability is exactly why it's the standard we all use today. And this really drives the point home. Look at the comparison. A bus failure? Everybody's day is ruined. It's a total catastrophe. A star failure? One person has to call IT, but everyone else keeps working. The choice couldn't be more obvious, right?
Okay, so let's zoom in on the modern standard, the star. Because this is where that whole physical versus logical thing we talked about becomes so important.
Here's the deal. The device in the middle of the star, that's what controls everything. If you use an old, kind of dumb device called a hub, your network looks like a star, physically. But logically, it acts just like that old, chaotic bus. It's like a room where everyone is shouting at the same time. But if you use a modern, smart device, a switch, then it both looks and acts like a star. The switch is like a smart mailman. It sends data only to the device that needs it. It's organized, it's efficient, it's just better.
All right, let's bring this all together. I want to give you a final, simple blueprint so you can understand pretty much any network you'll ever see.
It's a simple three-step plan. Number 1, just look at the physical layout. How are the cables actually run? Number 2, figure out the data flow. And you do that by looking at the device in the middle. What's calling the shots? And number 3, just remember the modern standard. 99% of the time, what you're looking at is a physical star network running on a smart switch.
And that kind of leaves us with one big question, right? We went from a handful of computers in an office to literally billions of connected devices. Our phones, our watches, our cars, our coffee makers, everything. The star topology has been amazing, it's served us so well, but as this insane level of complexity keeps growing, you have to wonder, what's the network map of the future going to look like?